Hey, welcome back today. I got a friend of mine, he brought me a pin from his mini excavator. Now, it's not the large pins like you're expecting. It's actually a door latch pin. Now, this pin's a pretty cool project because it transitions from a square to a round at the exact same size, within a couple thou. Let's quit standing around and talking, and let's get this job done. I grabbed some 1045 steel out of the drawer, and I had a bunch of ends left over from another job, which this worked out quite well. Now, the reason why I'm going with 1045 is it's got a bit of wear resistance, and I don't need to go with 4140 and super harden it, because if I was to do that, it's just going to wear the other part out. We want this to be the sacrificial part. The first step in this process is to find the ends on this so I can get my length, and then we're going to turn the diameter down to the finished diameter. Now, in some other jobs that I was turning stuff down in, where I had two steps, I would turn the major diameter down for both of them at the same time and then move on to the smaller one. However, you need to keep this really rigid, so I'm going to cut the first diameter down. This way, I have the bulk of the material that's still left on the secondary diameter, if this is making any sense, keeping everything rigid. Now, we're taking the final pass on this diameter. I know that this is going to be the final dimension because I zeroed it out on my last part that I cut out, and it's going to come back almost exactly every time. Then I know I have a certain amount above on my second diameter, and I just have to come close to it because we'll be cutting the final size on the mill machine. Now, if you're new to machining and you're watching this video, the chip should be coming off in 6s and C's, kind of little tiny little pieces, little bullets that shoot everywhere. You'll see I got little tiny spaghetti noodles that come off that are no longer than 2 inches. Now, if you ever have a situation like this, you should probably know better not to grab stuff while the machine's running like you saw there. My sincere apologies. Now, let's give this a measure and make sure it's within the 5 thou. Our next step in the process is to cut the snapper and groove. Now, the snapper and groove we're going to cut with a shop-built high-speed steel. And because we're running high-speed steel, I'm going to bump this down to, say, 500 RPM, give or take, just so that we're not going to burn the end of the high-speed steel off, and it'll last quite a bit longer. Now, for your benefit, I didn't put any oil on there, or I didn't put any coolant on there, so you can see a little better what we're doing. But really, in a production shop, you'd probably see some cutting oil or some coolant on there so that we don't burn the high-speed steel up. It was a lot of work to cut that high-speed steel part, and we don't want to ruin it. Let's throw this part back up in the wall and grab the parting tool and bump our speed up a little bit, and then let's part this tool off. The speed that I'm running for the parting operation might seem a little bit fast, but I'm trying to get above a frequency to get away from the chattering. I'm going to find the parting tool here on the face, then I'm going to move it over the width of the parting tool and zero it, and then we're going to go over the desired amount. I'm pretty sure it was something around 1.925, not to be exact. Now I'll do my death-defying monkey trick, and I'll grab this spinny, dangerous part that's super red hot, and hopefully not burn my hands or get wrapped into the machine. Remember everyone, don't put your hands near moving parts unless you lose a digit. Now that we're done that over on the lathe, we're going to bring this over to the milling machine here. We're going to put the indexing head up here, and we're actually going to notch 4 flats on these, and we'll be just about done. All right. Ooh, she's a bit of a mess. Now, let's grab our T-bolt kit and bolt this thing down. Now, probably a lot of people are going to watch me bolt this bad boy down, and they're going to see that I didn't tram it in or dial it in. Now, I'm not necessarily needing to tram this in. It's a small job shop. I'm going to be the last one to use this. So I know that I haven't dialed this in, and usually I'll write a little note on it. The key here is it's not going to change the geometry of the flat that I'm cutting because I'm cutting it along the horizontal plane. However, if I was cutting on the side of the part, it would make a colossal difference. I hope this is making a little bit of sense for you, but I'm cutting with the bottom of the end mill, which is going to be parallel no matter what, cutting with the side of the end mill would be a big deal, and it'd probably cut a taper into the work. So when I do production runs, I always make one extra part. And this is that one extra part. It's a little bit undersized, and this is the one that I'm initially going to start with and machine with. That way I can make mistakes on this one. Also, for the more experienced guys, this thing works really good for on the mill machine in tight places. So let's take a moment out of our day to talk about something that plagues not only the hobbyist, but even, the Red Seal experienced machinists. And I'm betting you can probably spot the problem here. If you look close enough, you'll probably figure it out. What's that? You give up? That's right. There's a clearance issue with the chuck and the mill machine head. Usually it's easily solved if you catch it early on enough. And sometimes it's as simple like today is I'm just going to grab a 3/4 inch end mill. This will not only give me a bit more rigidity, but it'll also increase the diameter of the cutter so I'm a little bit further away, and just further enough away so I can do my job. Now, the second common mistake is people don't always put it back to 0, and then all of a sudden they're calculating 90 degrees in a convoluted way, and that's when mistakes happen. So luckily today we remembered that, and we moved it back to 0. Now what I'm going to do here is I'm going to take my first cut, I'm going to set the knee to 0, and then I'm going to take one pass, cutting off some of the material, and then what I'm going to do is I'm going to rotate this 180 degrees to the opposite side, and then I'm going to take my cut. Now, because this part doesn't have to be exact, I mean, it's within 5 thou, I can get away with zeroing my calipers out on the original part. As you see here, I'm going to hit 0 once, twice, the third time. And then when I measure the flat across the other one, it's going to give me exactly how much I need to take off. Well, there's a bit of a catch. Not exactly what I need to take off, because I have to divide that by 2, because I need to take off half of each measurement from each side. Once I've done that, I'm going to take a test cut on both sides once again, and then I'm going to measure it, and then I'm going to continue on cutting the rest of the material. Okay, spoiler alert. This is one of the crappy parts, and I'm just going to go for broke. And I'm just going to cut 4 flats on it and hope that it's right. Because if I'm wrong on this part, I can just throw this part away, which I'm probably going to throw it away. And then I'm just going to stick the next good part in and then machine it from scratch that way. And today, this method has worked out quite well. And personally, I think this is one of the best parts of the video. But if you're getting bored of watching this work, you can scroll ahead to 9:13. And this is where we're going to cut the angle on the end of this part. This is a really good portion of the video, and there's more to be learned there as well. So with some very, very minor adjustments, and I mean like a thou or two along the way, we turned out an incredible product. The next step, which is not as accurate and works quite well, is we're going to cut the angle with the combination square. The key here is to make sure this part doesn't touch the bottom here and throw our angle out. This method is going to work quite well specifically for what we're doing here because the tolerances aren't super high tolerances. We can be in or out a degree. Now I assure you, we are not out any. In the end, we will show you. But there's also something to be learned here as well. It's important to note the way I have that end mill pulling it. If it's pulling it away from the work and it's going to push it down, we have less chance of breaking our end mill or messing up the part greatly. If I was to have it the other way, say I was to move it over a 1/2 inch on the other side and it was pulling the work up. Really sad things can happen really quick, costing me a lot of money. So we always got to be really careful which way the work's being pulled. Now, let's take this out of the vise here and match this up to the original and see how close this angle actually is. And hey, if you like this video, check out this video here. I know you're going to like it just as much as this one. And I've got lots of other videos, so why don't you check out the channel as well. Let's catch you on the next one and keep it safe.